Okay, number one, the northbound bus had been on the road at 60 miles per hour for 4 hours before the southbound bus left the same station at 50 miles per hour. So first thing I want to do is draw the picture correctly. They're leaving the same station, so I'm going to draw the station right here. We got a northbound bus, so he's going to go some unknown distance north. We got a southbound bus going some unknown distance south. I don't care that he left later or he's going faster, that doesn't matter to me. All I care about is they went somewhere. So the northbound bus left the station and traveled. The southbound bus left the station, traveled the opposite direction. They both went an unknown amount of distance, and there's nothing implying the distances are equal. And we want the buses to be 570 miles apart. So the total distance traveled by both is 570. The northbound bus is doing this much of it, the southbound bus is doing that much of it. So the northbound plus the southbound is equal to the total. And again, all this picture represents is distance traveled. So northbound bus went some number of miles we don't know, southbound bus some number of miles we don't know, total distance 570. Those are the only things I care about as far as drawing this picture. I didn't include the 4 hours, the 50 miles per hour, none of that matters when I'm drawing the picture. Now my categories are northbound and southbound. I got rate, time, and distance that I care about, and now I'm looking for rates and times. So it tells me very clearly the northbound bus is going 60 miles per hour. The southbound bus is traveling at 50 miles per hour. So they told us their exact speeds. The southbound bus left 4 hours later. So northbound bus 4 hours before, southbound 4 hours later. Take your pick how you want to establish that. But northbound bus is 4 hours before the southbound bus. So the northbound bus traveled for some amount of time, t. The southbound bus is just hanging out at the station for 4 hours before it heads off. So the northbound bus's time is more by 4, so t minus 4. So if the northbound bus travels for 5 hours, the southbound would have waited for 4 hours, then traveled for 1. So if you just want to test it out with some actual numbers, 5 minus 4 is 1. That makes sense for how they've got it established there. Once I know the rates and times of both, I multiply to get distance. So rate times time equals distance. So 60t is the northbound distance, that's this. And 50 times t minus 4 is going to be 50t minus 200. Make sure you redistribute that. And that represents this. And those two things add up to 570. So I would simply write 60t plus 50t minus 200 equals 570. So there's my equation created. The only variable in that equation is t, so I can find out what time is, and t represents the northbound time. That's what I'll find in this case. So I do plus 200 over here. Combine like terms, I get 110t is equal to 770. Divide by 110, I get t is equal to 7 hours. And it says, how long was the southbound bus on the road? All right, so how long was the southbound bus on the road? That's a question of time and southbound. So looking for the southbound time. We just figured out t equals 7 hours. T is in the northbound time. 7 minus 4 is 3 hours for the southbound time. So 3 hours would be the right answer. The other questions I may have asked, how far did the northbound bus travel? How far did the southbound bus travel? We can figure that out. 60 times 7 is 420 miles. 50 times 7 is 350 minus 200 is 150 miles. 420 plus 150 makes a 570, and they travel all together. So again, anything that we have a variable in a box here represents something that could be asked. Make sure you answer the question. This does not always answer the question. Number 2, Judy walked into the city at 8 kilometers per hour and then rode back home at 24 kilometers per hour. So Judy's somewhere. She walks into the city. She travels some distance to the city, so distance there. And then once she's in the city, she decides to go back home. So this is the distance back home. We're going to assume the city and her house are in the same place they were to begin with. So here's her house. She goes to the city back to the house. Distances are equal. Distance there equals distance back. Again, I don't care about speed, time, anything when I do this. All I care about is distance when I draw the picture. If I don't know what a distance is, I draw an arrow representing it, and then I draw the arrows going the right direction. Once I know the distances are equal, now I go to there and back are my categories. We got rate, time, and distance that we care about, and these 4 are the ones we don't want to fill in from what we read. She walked at 8 kilometers per hour. she rode back at 24 kilometers per hour. It was a long trip. She spent 12 hours traveling. So it doesn't say she walked for 12 hours, she rode for 12 hours. The total amount of time is 12 hours. So if she used up t hours going there, 12 minus t hours is left going back. So that's how you handle that. And it's going to be the same way on the test. It will be set up just like that, where t is 1, and whatever this number is, minus t is the other. All you can do is prepare for the test. I can't spoon feed you any more than that. That's being spoon fed in my opinion. So that's the structure. 8t is the rate times time there. 24 times 12 minus t is 288 minus 24t. Again, use distributive property. 24 times 12, 24 times negative t. The distances are supposed to be equal, so their distance equals the back distance. Move the 24t over. We get 32t is equal to 288. Divide both sides by 32, we get t is equal to 9 hours. So her time there was 9 hours. The question is, how far did she walk? How far is a question of distance, and how far she walked is 8t. So 8 times 9 is 72 miles. She really wanted to get to the city, apparently. But 72 miles, if we tried it out, this would be 3 hours. 24 times 3 is also 72 miles. We can see the distances are equal. So that gives us the answer. Number 3, Maxine bought 158 stamps for $23.80. She bought 5-cent and 20-cent stamps. How many of each kind did she buy? So we have 5-cent stamps and 20-cent stamps. We want to have number variables and value variables. And we're going to put value in cents because that's how they fed us the information. So let's say there's F 5-cent stamps and T 20-cent stamps, using the first letter of each of these to represent it. So 5-cent stamps are 5 cents each times F of them, so 5F is the value of the 5-cent stamps. T 20-cent stamps times 20 cents per stamp is 20 times T for the value of the 20-cent stamps. And if we start looking at the facts in the problem, fact number 1, $23.80, that's going to be about value. That's going to be 5F plus 20T is equal to 2,380. Be careful, this unit of currency is dollars, this unit is cents, so you got to move the decimal point 2 spaces over to make sense. In this case, everything divides by 5. It doesn't have to be done, but it makes the number smaller. So F plus 4T is equal to 476. If you don't know, the 2380 divided by 5 is that. You can always use a calculator, get your numerical values. All right, the second equation. She bought 158 stamps. That's a number of things, so we're going to use the number variables. That's F plus T is equal to 158. And now my system of equations has been created. If I change the signs, I'll make this negative F, negative T, and negative 158. Now the F's will cancel. So F minus F cancels. 4T minus T is 3T. 476 minus 158 makes 318. Divide both sides by 3, we get 106. And T represents the number of 20-cent stamps. So how many of each kind? So we have 5-cent stamps and 20-cent stamps. So T is the 20-cent. We got 106 of them. And we know she bought 158 stamps altogether, so if I do 158 minus 106, we get 52. So that's how many of each she bought. Number 4, Nancy has a box that contains 7 red marbles and 8 blue marbles. She randomly draws 2 marbles, one after the other without replacement. Notice, without replacement, that matters. What is the probability the first marble drawn is red, the second marble drawn is blue? So we're looking for probability of red first, blue second. So we're looking for 2 fractions here. Okay, what we have to do is establish how many marbles there are and how many marbles fit the description. So we start off with 7 red and 8 blue. So for the first probability, this one right here, there's going to be 15 marbles to choose from, which we can see very clearly there. And we're looking for red marbles on the first fraction, so there's 7 red marbles, so there's a 7 out of 15 chance that she picks a red marble. Anytime we do probability without replacement, we always assume we got what we were looking for. So I was looking for red on the first pick. There were 7 reds to pick from. I'm going to say that I picked one of those reds. Now there's only 6 red marbles left in the box. So the second probability, this one, the number of marbles in the box now is 6 plus 8, which is 14. Of those, 8 are blue. So we'll put 8 over 14 for the second one. And then I'm going to multiply, but before I multiply fractions, I always reduce if possible. Fraction times fraction, you can reduce diagonally or vertically. 7 goes into 14 2 times and 1 time. 8 and 2 go into 2, so that'd be 4 and 1. So on top I got 1 times 4, which is 4. On the bottom, 15 times 1 is 15. So the probability of getting red first, blue second is 4/15. Number 5, multiply. We got a binomial structure times a binomial structure, so it's just going to be a FOIL situation. I'm going to slide this down. First times first, positive 2 times positive 2 makes positive 4. Outside times outside, positive 2 times positive square root of 2 makes positive 2 times the square root of 2. Inside times inside, positive 3 square root of 2 times 2 makes positive 6 square root of 2. Last times last, positive 3 square root of 2 plus times positive square root of 2 makes positive 3 times 2. The 3 times the 1 makes the 3, and the square root of 2 times the square root of 2 makes the 2. And together, 3 times 2 is going to make 6 for that term. So, if I combine like terms now, I've got 4 plus 6 makes 10. And I've got 2 square root of 2 plus 6 square root of 2 makes 8 square root of 2. Number 6, multiply. This is the same kind of problem the last one was, except it says binomial squared. It's also got some letters in it, but that's not going to matter that much. So the square root of 3y plus the square root of 2z times the square root of 3y plus the square root of 2z. Notice how I wrote those. The radical goes all the way over the 3 and the y, so I'm making sure that I'm drawing it so it looks like the y and the z are both encased in the radical. Once again, this is a FOIL situation, so if I do first times first, the square root of 3y being multiplied by the square root of 3y makes 3y. Okay. If the y was not underneath the radical, it would be 3y squared. So be watching for that. If it looks like this, the square root of 3y times the square root of 3y, the square root of 3 times the square root of 3 makes the 3, y times y will make y squared. So I'm not sure at this point how I'm going to make the test, but it could be either way. I don't feel guilty about either way. So in this case, it's inside, so square root of y times the square root of y makes y, square root of 3 times square root of 3 makes 3. Outside times outside, positive times positive makes a positive. Square root of 3y and square root of 2z is just going to be the square root of 6yz. 3 times 2 makes 6. I don't want to see, I've seen people do this before, 3y, 2z. Don't do that. 3 and 2 make 6, multiply them together. But everything's underneath the radical, so multiply underneath the radical. 2 and 3 make 6, y and z make yz, everything underneath the radical. Same thing here, positive times positive makes a positive. 2 times 3 is 6, x on y and z is what we have as the letters. Again, everything underneath the radical, so it's all underneath the radical. And if I do last times last, it's going to be plus 2 positives. Square root of 2z times the square root of 2z just makes 2z. Last step is to add like terms. Those are both square roots of 6yz. They're both 1. So altogether my final answer is going to be 3y plus 2 times the square root of 6yz plus 2z. Number 7, find the equation of the line that passes through 1, 2, and 2, 6. You guys are still using graph paper to get slopes, so I'm going to go ahead and put some graph paper up here. If I don't remember to put that on the test itself, I'll make sure the sub knows that you need graph paper. So 1, 2, and 2, 6. I draw an x and a y axis. 1, 2 would be right here, and 2, 6, 2 over and 6 up would be right there. And I want to find the slope of that line. So what I'm looking at is a rise and a run. So I'm going 1, 2, 3, 4 spaces up. I'm going 1 space to the right. Both movements are positive movements. So my slope is going to be 4 over 1, which I'm just going to write 4. If you can write slope as a non-fraction, by all means do it. 4 is better than 4 over 1 in my opinion. Once I know what the slope is, now I take one of the 2 points, doesn't matter which one, I like this one better. And I'm going to use the y equals mx plus b structure. Anytime it says find the equation of the line, your goal is to get this structure for an answer. We didn't know slope, which we just found. We also need to know the y-intercept. We don't have that yet. So what I've got here is x, y, and m. These are the 3 values that I've got down here. B is what I don't know. So if I substitute the 3 things I do know, y is equal to 2. I'm putting that in place of the y. M is equal to 4. I'm putting that in place of the m. X is equal to 1. I'm putting that in place of the x. And b is what I don't know yet, so I'm going to keep that plus b. That just gets me 2 equals 4 plus b. If I move the 4 to the other side, I'm going to get b is equal to negative 2. So I know slope, I know y-intercept, and they go right here and right here. So y equals 4x minus 2 is the final answer for that one. Number 8, find the equation of the line. Again, same type of question, but this time the information they're giving us is different. It passes through a single point, not 2 points. It's parallel to a given line. So, how we find slope in a situation where it's parallel to a given line? The slope of the line they give me is the number in front of x. And if lines are parallel, they have equal slopes. So the last problem to find slope, I had to graph points and do a rise over run to find slope. This one, all I have to do to find slope is just use my eyes and see it's parallel to this, and there's y equals 1/4 x, slope is 1/4. I've got slope now. My slope is that, my point is 8, 5, and my equation is y equals mx, oops, I got those backwards, colors. Y in green equals mx in blue plus b. That's what the structure of the line, again, find the equation of the line, always go to the structure of the line equation. Slope is 1/4, x is 8, y is 5. So, if I substitute all my numbers in, y goes here, m goes here, x goes here, and then if I work it out, 1/4 of 8 is 2, and b would equal 3. Move 2 over, change the sign, subtract. So b equals 3, m equals 1/4, and again, this is the structure of my answer. Y equals mx plus b. So 1/4 x plus 3 is the right answer. Number 9, factoring. First thing I notice about this is x squared constant x. So these are in wrong order. So I'm going to rearrange. So 3x squared plus 9x minus 12. Okay. There's no equal sign here, so 9x is positive, 12 is negative. They don't change signs just because I'm moving them around. Next thing I look for, anytime I see the word factor, I'm assuming it means factor completely. Take out as much as we possibly can, anytime you can. First thing we look for is a common factor. 3 divides by 3 divides by 3. So I can take a 3 out. The leftover expression, if I take 3 out, is going to be x squared plus 3x minus 4. And that's just a basic quadratic trinomial, 1x squared, first term. So we're looking for factors of negative 4 whose sum is positive 3. 4 and negative 1 do the trick. So this, in parentheses, is going to be x plus 4 times x minus 1. And the common factor of 3 that was taken out is still out in front. There's my completely factored expression. So common factor, remaining thing is basic. On the test, number 9 should be the same way. They have a common factor, what's left over should just be a regular x squared trinomial, just a basic factors of it, it's on the chart. Number 10, same issue to begin with. the constant and the x are both in wrong order, so the first thing I'm going to do is rearrange it. So 2x squared plus x minus 1, and this is a 1x. If you put a 1 in there, maybe it helps you to understand that's what's going on. So x is positive, 1 is negative. I just rearranged the order. This one does not have a common factor, but now we have a number in front of x squared that we can't get out. So now we got to go to the more advanced factoring technique. We want factors of 2x squared, and I get that by, sorry, negative 2x squared. I multiply these two things together to get that number. So 2x squared times negative 1 makes negative 2x squared. The sum of those numbers should be positive 1x, and that's whatever this is. So if I'm trying to find ways of doing this, positive 2x and negative 1x do the trick. Multiply those, you get negative 2x squared, add them, you get positive 1x. So I'm going to change this object into these two objects, and I've got choices of order. I can put the 2x first, then the minus 1x. I can put the minus 1x first, and then the 2x. If we consider there's four places, 1, 2, 3, 4. If this place can be positive, it's helpful. So I'm going to do this. 2x squared is going to stay 2x squared. Minus 1 is going to stay minus 1. I've got to put these two guys in place of this one guy. I'm going to put plus 2x here, so that third term's positive. I'll put the minus 1x there, so that second term is whatever it is. I don't care about the second term or the first or the fourth. If I can make this third term positive, so if there's a positive choice here, make sure it goes in the third position. So once I get my 3-term polynomial broken into a 4-term polynomial, group. By making that third term positive, we got a plus sign in the middle. That's what we want in the middle. It makes life easier. Common factor of the first group is x. If I take x out, I get 2x minus 1 left over. Second group doesn't have a common factor, so officially plus 1 is its common factor. 2x minus 1 is left over. And then at this point, what should happen, if you did everything else right, is that these guys here should be exactly the same, which they are, which means my factored form for this is going to be 1 parentheses containing 2x minus 1, a second parentheses containing x plus 1. Notice the parentheses being multiplied together. Okay, sometimes people put plus because there's plus between these. That's not what happens. Common binomial factor is factor 1. Greatest common factors is factor 2. If there is no common factor, make sure you write that plus 1 so you actually have something to look at that you can write down there. So, there's our final answer. Number 11, radical equation. Job 1 of radical equation is get the radical by itself. So I'm going to move the 4 over here. That leaves me with the square root of x plus 2 is equal to positive 7. Step 2, square both sides. Get rid of the radical. Square root of x plus 2 squared is just x plus 2. 7 squared happens to equal 49. Step 3, solve for x. That right there represents the only number that could possibly be the right answer to this problem. The last step is to verify that it actually works. We go back to the original problem as it was originally written. I got the square root of minus 4 plus 3. What goes in the square root is this number plus 2. So 47 plus 2. 47 plus 2 is 49. It's supposed to equal 3, sorry. So, changing x to 47, square root of x plus 2 minus 4 equals 3. 47 plus 2 is 49. Square root of 49 is 7. 7 minus 4 equals 3 is true. So that means that's a good answer. If this came out false, then we throw it out. I'll say on the test, expect it to work. Don't expect an empty set on the test. Number 12, factor by grouping. We just did this a moment ago. It's going to work the same way. This one's just already ready to go. We don't have to modify anything to make it happen. So if I'm going to factor by grouping, I'm going to group my first two together. That's going to be wy minus xy. Group my second two together. It's going to be plus parentheses wz minus xz. Third term position is a positive, which puts a plus there. Again, everything's great with that. We like to see that happen. Next, I'm going to factor each one of the binomials here. Common factor of y in these two terms, take a y out, w minus x is left over. Common factor is z here, take out a z, and w minus x is left over. W minus x matches w minus x, so that means that w minus x is factor number 1. y plus z is factor number 2. Again, these two factors are being multiplied together. Every time you get a factor problem, you're multiplying the pieces together. You're not adding or subtracting the pieces. So factor 1 is the common binomial. Factor 2 is whatever the common factors were. 13, find C. Abstract equation with fractions. First thing I want to do is get rid of all the fractions. Makes the problem simpler and much more manageable. So I'm going to multiply by BMC, the least common denominator of the three fractions. When I multiply BMC times A over B, B cancels B, so AMC is left. When I do BMC times X over M, M cancels M, BCX is left over. When I multiply BMC times 1 over C, the C cancels C, minus 1 times BM is left over. And when I do BMC times P, there's no fraction at all, so I just get BMC P. Make sure all that's done correctly. Take your time through that step to make sure every piece has exactly what it is. And write neatly enough so you can see what each letter is. I've seen people changing letters to different letters. Sometimes T's change to plus signs, that kind of stuff. So be careful with the way you write things. Once you've done that, now what it is we're solving for matters. So it says find C. So looking, this has a C, this has a C, and this has a C, and that doesn't. So I need to get all the C stuff on one side. So it looks like a couple C things are over here. So I'm going to move the BMCP to the left, the BM to the right. The other option would have been to move both of these guys over to the right, leaving the other two where they are. As long as all the C's are on one side, all the non-C's are on the other, it doesn't matter how you do it. So I've got AMC plus BCX. Those guys didn't move, so they're staying positive. BMCP is moving to the left, becomes negative. Minus BM moves to the right, becomes positive. The things that move change sign. Moved became negative, moved became positive. Once you've gotten all your terms containing this letter to one side, that letter is going to be a common factor, so take it out. So C is a common factor, take it out. AM is left from the first term, plus BC is left from, or sorry, plus BX is left from the second term, took the C out. And minus BMP is left from the third term because we took the C out. Still equals BM. Nothing's happening to the right-hand side in that step. Okay, final step. C times something equals something. When you get to this point, whatever is not multiplied by C is the top, whatever is multiplied by C is the bottom. So we write the answer. C equals the top, BM, over the bottom, AM plus BX minus BM. Do not expect reduction of fractions to happen. So once you get that answer, just circle it and move on to the next problem. Number 14, divide. Okay, polynomial division. We're dividing by a binomial, so x minus 1 goes outside, and x cubed plus 0x squared minus 3x minus 1 is our polynomial that we're dividing into. X squared is missing, so I put a 0 term to represent an x squared term that contains absolutely no value. So this isn't going to do anything, it's just creating space. And division is what it always has been. We divide first by first to get an answer. So positive x cubed divided by positive x makes positive x squared. X squared times both things, so only divide by one but multiply by both. X squared times x makes positive x cubed. X squared times negative 1 makes negative 1x squared. Subtraction, next, subtraction is changing signs. So x cubed becomes negative, x squared becomes positive. Combine like terms, x cubed minus x cubed cancels. 0x squared plus 1x squared just makes 1x squared. Again, that has no value, so it's not changing anything. This is what it is. I was just creating space, so it had an x squared to deal with. Minus 3x and minus 1 move down, and we repeat the process. Positive x squared divided by positive x is positive x. X times x is x squared. X times negative 1 is negative 1x. Subtraction is changing signs. X squared becomes negative, x becomes positive. This is 1x. Combine like terms, x squared minus x squared cancels. Negative 3x plus 1x makes negative 2x. Bring down the 1, repeat the process. Negative 2x divided by positive x makes negative 2. Negative 2 times x is negative 2x. Negative 2 times negative 1 is positive 2. Subtraction is changing signs. 2x becomes positive and 2 becomes negative. finite terms, negative and positive 2x cancel. Negative 1 minus 2 makes negative 3. These signs are the same, so I add them together, and they're both negative, so it's negative. Once I run out of x's, that's the remainder. The remainder is negative, so I put a minus sign, fraction bar, remainder over divisor. Divisor is whatever that is. And there's our whole quotient, remainder included. Number 15, a base of the right solid 7 feet high is shown. Find the surface area of the right solid. So, surface area of a right solid is 2b plus ph. B is the area of the base. So B is how much space is inside of that. P is perimeter. So P is how far around it is. And H is the height of the solid. So just know where to look for things on this one. The height's going to be in the words, and the area of the base will be whatever the area of that thing is. Trapezoid plus semicircle. Perimeter is just the sum of all the pieces. So let's start with perimeter because that's easier. 5, 8, 9 are all known. This side here is going to be 3 pi. Anytime you have half a circle, it's just pi times the radius. 3 pi is about 9.42. So the perimeter of this thing is going to be 5 plus 8 is 13, plus 9 is 22, plus 9.42 is 31.42. B is the area of the base. Again, we have a trapezoid. How you want to deal with the trapezoid is up to you. You could do a trapezoid area formula, or you could do a rectangle with a triangle attached to it. Let's do it that way, because I think most of us are still kind of in that mode. So if I draw this height in like so, this is a rectangle, so opposite sides equal. That's 5, this is 5, this is 6, because radius up, radius down, 3 up, 3 down is 6, so this is 6. This is at a right angle. That's 9, this is 5, so this must be 4. So if we look at the triangle, triangle is 1/2 times the base of the triangle times the height of the triangle. 4 base, 6 height. Half of 4 is 2 times 6 is 12. The area of the rectangle, rectangle is length times width, that's 5 times 6, which is 30. And the area of the semicircle is pi r squared divided by 2. So perimeter is pi times radius, area is pi r squared divided by 2, both for half a circle. 28.26 divided by 2 is 14.13, using 3.14 for pi. So 12 plus 30 is 42, plus 14.13 is 56.13. And again, h equals 7. Once I know all three of these numbers, I just apply the surface area formula. Surface area equals 2 times b plus p times h. So, if I double 56.13, I get 112.26. Multiply 31.4, 2 times 7, 4, carry the 1, 9, carry the 2, 9, 219.94. I want to verify that with my calculator. 31.42 times 7 is 219.94. 2 times 56.13 is 112.26. So if I just add those up, we get 332.2. Feet is the unit here, so it's going to be feet squared. Expect a similar figure, probably different dimensions, different height, different something. So, but same type of figure, triangle, rectangle, semicircle, probably creating it. So know your formulas, know how to use the formulas appropriately. And again, identify each thing, find this, find this, find this, and then just simply apply the formula. Do it in pieces, don't try and do it all at once.